Okay, this is really a pretty easy assignment. I should have probably given you more, but I didn't want to because the next lesson is confusing. Okay, and it's a Monday, so let's just keep it simple. There's three parts to this, all pretty easy. Identify the domain and range of each relation. Determine whether the relation is a function. So, we've done domain and range before. Each coordinate is represented with xy, okay? xy. The x's are your domain, so you got 3, 3, 3, 3, and 3. The ranges are your y's, so you have 7, 8, -2, 4, and 1. Now, here's what you write. Function or non-function. Here's how you determine that. Circle your domain. Do you have any numbers that repeat themselves? Yeah, obviously, okay? That is not allowed. If you have numbers that repeat in the domain, it's a non-function. You don't care about the range. The range, I want to see the range, but you don't use the range to determine whether you have a function or not. Okay, next one. xy, 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 xy. So the domain, you have 6 for the x, 6, 5, 1, 7. The range, you have -7, -8, 4, and 5. Those are your y's. Domains are the x's, the range are the y's. So function or non-function. Okay, look at your domains, okay? Do you have any repeats? No, we don't. They're all different, so that's a function, okay? Next one, xy, 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 xy. Now I'm ready to identify my domain and range. The domain is your x's, 0.04, 0.2, 1, and 5. Excuse me, 1 and 5. The range, you have 2, 1, 5, and 25. So the question is function or non-function. Okay, look at your domain. Do you have any repeats? No, 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 nope. So it's a function. Okay, next one. Okay, your x's are your domain, so you have 4, 1, 0, 1, 4. For y's, you have 2, 1, 0, -1, -2. Function or non-function. Okay, well, we have repeats in the domain. I mean, we have these two repeating and these two, so that's a non-function. You cannot have repeats in the domain. That's a non-function. Okay, that's pretty easy, I think. Maybe you disagree. Okay, write a function rule that represents each situation. This is similar to what you did last Friday with the table, but you're not going to make the table. The price P of pizza is $6.95 plus 95 cents for each topping T on the pizza. Make a line and put equals P. The price starts at $6.95, then you would add 0.95, but you would add it over and over for every topping, so put T. So there's your function. 6.95 plus 0.95 multiplied by variable T equals P. Okay, the load, L, in pounds of a wheelbarrow is its own 42-pound weight plus each 4-pound brick, B, that it carries. So, equals L. So if I had a table, I'd start it with 42. Then I go 0, 1, 2 in the other column, and every time there was 1, I would add 4. So 4 times b. Okay. So 42 plus 4 times b equals L. There's the equation. Okay, the amount of extract A in an 8-ounce bottle decreases by one, that's supposed to say ounce, O-U-N-C-E, by 1/6 of an ounce for each batch B of waffle cookies made. Okay, so equals A. Now you start with 8 and you add, but when it's decreasing you add a negative 1/6 times B, variable B. It's negative when it decreases. So you can either write 8 plus negative 1/6 times B or 8 minus 1/6 times B. It means the same thing. I usually go plus negative, but that's just me. You can write it like that, or you can just write 8 minus 1/6 times B equals A. You can do the plus negative or the minus. They mean the same thing. Okay, a burst pipe has 37 inches of water, W, and it decreases at a rate of 1.5 inches per hour. So, instead of equals Y, we're going to put equals W. Now the W begins at 37, and then it decreases, so it would be a negative 1.5 times H. Again, you can write it like that, or you can just put 37 minus 1.5 times H equals W. It's up to you. Okay. Now the last part. This is pretty easy. Now, before what we were doing off coordinates is finding the domain and range and see if it was a function or non-function. Now we are going to look at a graph and see if we have a function or a non-function. Okay. It's called the vertical line test. Here's a bunch of coordinate points. You don't need to label what they are. We'll get into that later. Okay. By the way, this coordinate here, you'd be backwards. Don't write this down, but I'll show you how to label. Don't write it down. So to label that coordinate, this is the X and this is the Y. Okay. So you'd start at the middle to get to that point. You'd move left, so you count by negatives. -1, -2, -3, -4. So that's -4. And then you'd move up, so for the Y you count by positive 1, 2, 3. Okay. Now I'm not going to do that. Okay. You could list out all the coordinates and see if you have any repeats for the X's, but I'm not going to do that. There's an easier way. Vertical line test. Vertical line, you make a line up and down through each point. Okay, so I went through one point. So far no repeats. Here I go through 2 points, so I can stop. I have repeats, so that's a non-function. If you do it all the way to the end without any repeats, then you have a function. Now the next problem, this is called a discrete graph, just a bunch of points. This is called a continuous graph. Here's how you do a continuous. You just make a vertical line, one vertical line through the whole thing. How many times did that cross our little graph here? Twice. Once, twice. That's a repeat. That's a non-function. Okay, next problem, another continuous graph. Again, it's got to be a line up, down, not across. It's vertical. How many times did that cross our graph? Just once, so there's no repeats. That's a function. Okay, there's the line. That's continuous. How many times did that cross the graph? Once. Just once would be a function because there'd be no repeats. Okay, alright, that's really all I have to say on that. Okay. Yep, and you go do the assignment. The assignment's kind of out of order, but just do the problems.